In grade 9, we were introduced to scatter plots. And that was where we had two types of data where neither factor was necessarily an independent variable. So we were always taught you put the independent variable on the x-axis, the dependent variable on the y-axis, and there you go. But if you had something like this, where we are looking at time and time, these are two variables that don't actually depend on each other. So bivariate data here. But what is helpful is to see, is there any kind of relationship between these two things? So here we've got just a scatter plot of the marathon results for the Cape Town Marathon that was recently run. And there are a number of athletes who ran, and they put in however many hours of training. The further we go along this axis, the more they trained. And then this is the time they took to finish the race. And what we want to do is we want to say, well, is there a relationship between how much we train and the time it takes us? Because obviously you want to run a marathon in as short a time as possible. So that's known as a scatter plot. And then what we were introduced to is what was known as a line of best fit, where we would try to place a line here, a straight line, to try and then see, can we determine some other results from this data? Now, up until grade 12, this line of best fit is essentially just our best educated guess. Where can we put a line so that we have a similar number of scores below the line, above the line, and you don't really want it to be influenced by outliers. So, for example, someone who really didn't train that much but seems to have run an exceptional time, or someone who trained a lot but seems to have taken much longer than you'd expect to complete the race. So that was the line of best fit, but this year we move on and we learn about the least squares regression line. And that helps us to actually say, well, if I'm given all of these data values, how can I very accurately determine the equation of this straight line? And then, can I base some data off that? So now, if I wanted to figure out, if I had my least squares regression line here, and I wanted to try to determine if an athlete ran or trained rather for this many hours, what kind of results could we expect from the marathon? And we could pretty much try to read that off the graph. Now that would be something that is very accurate, and it is known as interpolation. So if I have at least one data value on this side, at least one data value on this side, I can do, obviously with a ruler and some accurate measurements here, I could give you a very good estimate of the data. So interpolation, good, we encourage that. But what happens if I try to read something here? Let's see if someone really didn't train at all. Can I try to figure out what their time is here? Or if someone trained for an extensive amount of hours, could I try to read off the graph here? Now I could do that, but that is quite unreliable, and so we don't encourage that. That's known as extrapolation. So in a test, we like to ask this. We like to say, okay, can whoever, the data scientist, can they try to determine someone's reading here? Would you encourage them to do that? Yes, we would. It's interpolation. Can we encourage someone to try and read data here or here that lies outside of the scope of the data points we were given? No, we can't rely on that data because it is extrapolation. So learn these two words and make sure that you can use them to justify your answers. The other thing that you may remember from grade 9 when we were introduced to scatter plots is being able to look at a scatter plot and then interpret some measure of correlation. So in other words, can I see a relationship? That's probably a nice way to break it down. Correlation is, what is the relationship between the points and these two variables of data? Okay, so in some instances, if the points are really scattered everywhere, then we would say there's no relationship or even no linear relationship, because you could possibly get a parabolic relationship or something like that. So that does come up, but generally we work with linear relationships. Okay, here on the second one, if we were to draw in the least squares regression line there, it would be a line with a negative slope. So basically, as one variable increases, the other variable decreases. And so that would be a negative correlation. And then the opposite is also true. So as one variable increases, if the other one also increases, then we have a positive correlation. But again, the great news is that we no longer have to try and just make an educated guess. We actually have tools now at grade 12 level where we can really interpret our data in a far more accurate way. So if we enter all of these values into our calculator, we enter all the x coordinates, all the matching y coordinates or corresponding y coordinates, we come up with what is known as the correlation coefficient. And that is any number between -1 and +1. And so once you've got a correlation coefficient, you can start to then interpret, is it strong or is it weak? So I always tell my students, you need to give a two-part answer. You need to say, is it positive or negative? And then is it strong or is it weak? Okay, so here we can already see positive or negative. And then the closer the points are clustered together, that affects the strength of it. So looking at your correlation coefficient, once you've worked out the R value, okay, the closer you get to 1, the stronger and more positive the correlation is. And if you move in the other direction, so towards -1, again, the stronger and more negative the correlation will be. Okay, so in these two scatter plots, I'd say the correlation is going to be very strong, and so we'd probably end up with a score somewhere at least above 0.7, and so we could say this is a strong positive or a strong negative. Okay, if you end up with a correlation coefficient of 0, which is quite likely in something like this, then there's no correlation, okay, or again, no linear correlation. And so that's how we interpret correlation coefficient. The closer it is to either -1 or +1 tells us the strength of it. And then obviously if it's negative, we have a negative relationship. And if it's positive, a positive relationship. Now the correlation coefficient is something that we can work out on our calculators. And here are the steps that we would follow. So we're going to look at the steps and then we are going to practice an example together. Okay, so it says here the correlation coefficient, these are what we do. So we're first going to start off and just push mode. And then we want to choose option 2, which is going to take us to statistics. Okay, so grab your calculator, follow with me, make sure that you know how to do this. Okay, now in the past, we're working with straight line, it's the line of best fit here. So in the past, we've always had y equals mx plus c, okay? Don't be thrown by the fact that now they've changed the c and the m value, or at least the variables for those values. That's the road we're going to go down, okay? And if we choose that option 2, it'll help us get not only the correlation coefficient, but also the variables that we need for that least squares regression line. Okay, so mode, then we want option 2 for stats, and then again we want to choose 2 because that takes us here to a plus bx. And then what we do is we enter the data. So our calculator gives us a table here to fill in. We enter our x coordinates and our y coordinates, or whatever the two variables are, because remember, there isn't a dependent and an independent variable. We can enter them in the order that they get given to us. And then you want to push this AC button. So you don't want to clear the memory completely. You want to push AC. And now we want to actually answer the question. So what is the correlation coefficient? And so to do that, we go shift, and then we push the number 1, and then we choose option 5 for regression, and then we choose R for correlation coefficient. Okay, so jot those down because just now in the example, we are going to practice the correlation coefficient. But before we move on to that, let's check that we also know how to work out the line of least squares regression on our calculators. The process starts off very much in the same vein. So we again need to get our calculator into stats mode. So we go mode, then we choose option 2 for statistics, and then again we choose 2 because we are looking for this line, this equation of the line. Okay, once we're there, we can enter the data that we are given into the table, and then you don't want to wipe it away, you don't want to switch your calculator off, we just want to clear for now. And then what we want to do you see that there are two variables here that we'll work out? We need A and we need B. Okay, A is going to be the y-intercept, believe it or not, of this data. and b is going to be the gradient of the straight line. So we still are working very much with the straight line equation, but we're going to need to do this step here more than once. So first of all, we're going to go shift 1, because that's going to give us all our statistics options. We're going to choose 5 for regression, and then we're going to start filling in these variables. Okay, what is the a value? So to get that, we say option 1 and equals. Then we're going to clear the data, and we're going to try, or clear that calculation rather, and then we're going to go through the process again. So shift and 1, we don't have to re-enter the values in the table, fortunately. We're going to choose 5 for regression, and then 2 for option B. Let's practice this now with an example. Right, so consider the bivariate data in the table. Why is it bivariate? Because they're just two variables, neither of them depends on the other one. Okay, question 1, determine the correlation coefficient. Question 2, comment on the nature and strength of the relationship. So that is very much linked to our interpretation of this correlation coefficient. And then determine the equation of the least squares regression line, a plus bx. Okay, so there we have it. Our calculator is going to help us do this. So the first thing we're going to do is we're going to get it into stats mode, so mode option 2, and then why don't you pause the video and see if you can go through all the steps to type these values in the table, and then hit play, and let's determine the correlation coefficient and this least squares regression line together. Once the data is in the calculator, in other words, we've added the table, we then push the AC button, and then we say shift 1 to give us these statistics options here, and we want to choose 5 for regression, and now we want to answer the question. So correlation coefficient, that is R, and you will see that that's option 3 on the calculator. So that's the first thing we're going to do. So we're going to say 3 and equals, and there we get a correlation coefficient of 0.81. All right. Question 2 is asking us to interpret that. So comment on the nature and strength. Okay. Nature, is it positive or negative? This is a positive answer here, meaning as one value gets bigger, so does the other one. So it is a positive one, and 0.81, anything greater than 0.7, I would say is strong. So this is a strong positive correlation. Okay, and now, without clearing our calculator, we're going to determine this equation of the least squares regression line. So we're going to say AC, because we want to get rid of what was on the screen currently. We want to get back to these stats options, so shift 1 to give us that. Again, to option 5 for regression. And now remember, we've got two variables in our equation there. So the first one we'll work out is the A value, so that's option 1. We press equals, we get 1 comma, and now it's important to read the question, because it'll tell us how many decimal places we need to use. If it doesn't specify, then you go with whatever's written on the cover page of the exam, which is generally 2 decimal places. So let's go with that, 1,21, that's going to be our A value, plus, now let's clear again the calculator, so AC, and then we're going to go again, shift 1, so we're just going to follow the same process. Option 5 gives us the regression, and now we've already got A, let's find out what B is. So 2 and equals, and that's going to give us that second part there of the equation, so plus 0.74, if we round off to 2 decimal places, X. Okay, so what do we know? If we were asked now to plot this line, we could very accurately work out, okay, we've got a y-intercept here. I can write it for you in standard form, but it is better if you can just see it without that, because it's going to save you some time. So 0.74x plus 1,21. Okay, so I can see the gradient is positive, and this is my y-intercept. Okay, it's just the c value of an equation, or in this case, new stats terms, the a value. And then if I've got a y-intercept, how do I work out an x-intercept? Well, I just let y equals 0. So if ever they ask you to actually plot or draw this least squares regression line, please remember that we've got to move on from our grade 9 understanding, we can't just do our best effort to do what we think is an educated guess. We actually need to work out this equation using our calculator, and then we need to accurately work out the x and y intercepts, and then we can plot it. But there you have it. Thanks to our calculator, we can easily work out the correlation coefficient. We can accurately describe the nature and strength of that. And there's no longer a line of best fit. It is now a least squares regression line, which is a very accurate representation, so that we can use that interpolation to really make some good predictions about, or good estimations about the rest of our data.